Hi, everybody. I'm going to go over a Unit 5 study guide with you, so let's get started right away. Select all the functions whose graphs include point 16, comma 4. When I have something like this, then that means I have an x value and a y value. So my x value is 16, my y value is 4. So all I would need to do is plug them into the equation. If it makes a true statement, then that means that ordered pair is on the graph of that function. If it doesn't make a true statement, then it's not on the graph. All right, so let's start off with a 4 equals 16 times 2, or 2 times 16. Well, that's not going to work. 16 times 2 is 32, so that doesn't work. All right, B, 4 equals 16 squared. Well, 16 squared would be 16 times 16, and that's a large number. Let's see. 16 times 16 is going to be 256. Nope, that won't work. All right, next one is going to be 4 equals 16 plus 12. Nope, that's not going to work. Way too big. All right, next one is 4 equals 16 minus 12. Finally, 16 minus 12 is 4. That is correct. So this one works. And then the next one is 4 equals 1/4 times 16. 1/4 times 16 is the same thing as saying 16 divided by 4, okay? And I know that 16 divided by 4 equals 4. So 4 equals 4, check. That's a true statement. So my answers are D and E. Alrighty, so let's go back to my mouse so I can scroll. Okay, cool. Next one. This graph shows the temperature in Diego's house between noon and midnight one day. So we had one like this in our homework. So that means 1, 2, 3, 4, 5, they equal 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock in the afternoon. Okay, perfect. Select all the true statements, same thing. You want to go ahead and make sure you read it carefully and have to go through all of them. Time is a function of temperature. Time is a function of temperature. Well, we've been talking about this in class, like the last couple of days especially, that this and this. So this first one, the first one would need to be the output in order for it to be a true statement. And that first one is actually the input because it's on the y-axis. So this is a false statement because it should be switched, should be temperature and time. So that's not true because it's not the output, right? So the lowest temperature occurred between 4 and 5. So let me go between 4 and 5. Actually, that looks like one of the higher temperatures. So nope, the lower temperature is going to be over there between 11 and 12. The temperature was increasing between 9 and 10. If I go up to 9 and 10, looks like it's decreasing during that time. So that's false. The temperature was 74 degrees twice during the 12-hour period. 74 degrees is approximately right here. So I would just have to go straight across, and it looks like it's going to be 2 different times. So that is true. There was a 4-hour period during which the temperature did not change. Well, this flat line right here, that means that it didn't change because it stayed the same temperature. So between 5, 6, 7, 8, yep, there's a 4-hour. Between 5 and 9, it didn't change. All right. Oh, let me get the eraser here so I can erase some of this stuff. Okay, there we go. Pen. Oh, I keep doing that when I'm trying to scroll. Okay. All right, this table shows a linear relationship between the amount of water in a tank and time. Which of these statements is true? Again, it's kind of like a select all, same type of thing. You have to look through all of them. So I noticed that they're talking about slope. They're talking about increasing and decreasing. They're talking about rates. So let me just go ahead and stop and let me find the slope of this. All right. This is X. This is Y. I notice that this is going down by 10. and this is going up by 5. Okay, so the change in my y is -10. Change in my x is 5. So in gallons per minute, because that's y over x, gallons per minute, it's going to be -10 over 5, which would be -2 gallons per minute, right? Or decreasing, okay, because it's the water is going down. So the water in the tank is increasing. Well, it says increasing, so that's not it. The water in the tank is increasing at a rate of 10 gallons. Nope, that's not it. It says increasing again. The water in the tank is decreasing. Here we go, these last two. The water in the tank is decreasing at a rate of 2 gallons per minute. I think that's true. The water in the tank is decreasing at a rate of 10 gallons. Nope. So that one is just the one answer choice. Elena goes for a walk. The graph shows her time and distance traveled throughout the walk. All right, cool. Lots of stuff is happening here, but first question, what is the independent variable? And because I don't have space, I'm going to write up here. The independent variable, if you look back in your notes, is the variable on the x-axis, also known as your input, okay? And that is time in hours. So you could just say time. You could say time in hours, okay? What is the dependent variable? That's the other one that's on your y-axis or your output, and that's distance. Fill in the blanks correctly. Blank is a function of blank. We talked about this. So when you fill this in, this needs to be the output. This needs to be the input, also known as the dependent variable and independent variable. Okay, so blank is a function of blank. So distance is a function of time. Distance goes in the first blank, time goes in the second blank. Distance is the output or the dependent variable, so it needs to go first. It's kind of like doing it backwards. What is the output when 3 is the input, and what does that mean in this situation? 3 is the input, so this would be 3, 7. So the input is 3, the output is 7, okay? So 7 is the output, and what does this mean? This simply means that at 3 hours, Elena walked 7 miles. Okay, hours, miles. All right, these tables correspond to inputs and outputs. Which of these inputs and output tables could represent a function rule, and which one could not? Explain or show your reasoning. Okay, so we learned at the beginning of Unit 5 that in order to be a function, one input can only have one output. They can share an output, but one input can only have one output, okay? So as long as your input only has one output, okay, then it's a function. So mainly I want to look at the inputs. So if I just take a look at the inputs, and if all of them are different, then for our purposes, then it would have to be a function. So -2, -1, 0, 1, 2. Every input has an output. We're good to go. This is a function. This one could represent a function rule. All right, table B, 4, 1, 0, 1, 4. Okay, I want to always look at the inputs first, and I notice that 4 is repeated, and it has a different output. 1 is also repeated, and it has a different output. So 4, -2, and 4, 2. Right there, I could tell you that one input has 2 different outputs, so this is not a function. All right, next one, we have 1, 2, 3. No inputs are repeated. They all have the same output. That's okay, though. Just like people can have the same birthday as long as each person only has one birthday. Each of these inputs only has one output. But then when you take the function, you flip it around, you flip the outputs and inputs around. My input is repeated 3 times with 3 different outputs. So this is another no, no, no. All right. Oh, is there more? Yeah, okay. The graph represents an object that is shot upwards from a tower and then falls to the ground. The independent variable is time in seconds, and the dependent variable is the object's height above the ground. How tall is the tower from which the object was shot? So this is all about critical reading. So if you notice the difference in this area and this area is that this one starts at 10 and this one goes all the way down to 0. That means that it was shot from a distance above the ground, which is a tower, and then it goes back and hits the ground, right? How tall is that tower? Well, wherever it started from, that's your y-intercept, okay? How tall is the tower? Well, it says 10. 10 what? 10 meters. Okay, because it didn't start at 0. It started from a distance off the ground, which would be the tower. So that's 10 meters. When did the object hit the ground? So when? How long did it take it? So I already have that point marked, and it looks like it hit at 6 seconds. Estimate the greatest height the object reached and the time it took to reach the height. Indicate this situation on the graph. All right, I'm thinking the tallest point is approximately right there. And I would say that it's 3 seconds it took. And the greatest height was going to be 93 meters. Okay. All right. Last problem. All right. 2 plumbing companies charge money for each hour of work plus a one-time fee. We got A plus plumbing and we got quality plumbing. A plus has a table, quality has a graph. We're going to be comparing lots of stuff about this table and graph. Like the y-intercept or the initial value and the rate of change. All right. I'm thinking back to the Domino's pizza problem when I'm looking at this table. So I'm looking at the table and I'm going to go to A. How much does A plus plumbing cost for each hour of work, and what is the one-time fee? Okay. I need my pen. There we go. Okay. All right. So I have some stuff going on here. Now, if I want to know what is the one-time fee and what is the cost for each hour of work, first I need to find the cost for each hour of work. Then I can go back and find the one-time fee. So there's several different ways to do this, but this is an X, this is a Y. All right? I taught you how to find the slope when you have 2 points. Simple as that. I could take my 2 Y values, subtract them. Take my 2 X values and subtract them. Okay? All right, so I get 180 over 3. Okay? I'm going to divide that, and I get 60. All right, this is my slope or my cost for each hour of work. How did I find it? I found the difference in the Y values by subtracting them, and the difference in the X values by subtracting them, and I end up with $60 per hour. Now, the last thing I need to do is find my initial rate, because if I charge $60 per hour, well, 1 hour costs $140. So obviously there is something in the beginning, because if it was just $60 per hour, it would be 160, 2, 120, and that's not how it's working. It's 140. So what I need to do is I need to find my zero value. So I need to work backwards and I need to figure out the cost for zero, or my initial value. All I need to do is subtract 60 from 140. So all I need to do is subtract 60 from 140. So 140 minus 60 gives me 80. So my initial value is 80. Okay, how much does cost for each hour of work? $60 per hour, and one-time fee is $80. Okay. All right, let's go to quality plumbing. And we have to look at the graph for this one. So same question. Each hour of work, and what is the one-time fee? So this time we have to look at the graph. All right, so to find the slope on the graph, I just need to find 2 points and draw a triangle. Remember that? Let's see, it goes from 150 to 200. So my vertical change is 50. My horizontal change is 1. So it's going to be $50 per hour. One-time fee is going to be my y-intercept, and it looks like the graph starts at 150. Can A+ plumbing and quality plumbing ever charge the same amount for the same amount of time? Explain or show your reasoning. When are they the same? Do you guys remember that? That's systems of equations. When are they the same? So all we would have to do is write 2 systems of equations, set them equal to each other, and solve. So my first equation for A plus would be 60, let's use H, plus 80. So 60H plus 80 would be $60 per hour plus 80. And quality would be 50H plus 150. There's my 2 equations. Now, if I can get a solution for H, then that means they can equal each other. Cool? Great. Let's start by subtracting 50H on both sides. 10H plus 80 equals 150. Subtract 80, subtract 80. Okay, so I get 10H equals oops, 70. Finish it out and divide by 10. So the hours, they're going to be the same, is 7. Now we need to know the cost when they're the same. So then I just need to plug 7 into one of the equations. Doesn't matter which one. I'll take the top one. I'll use a different color so you can see this better. So I'll take this one. So 60 times 7 plus 80. I got $500. So they're going to be the same at 7 hours, and they're both going to cost $500. But I'll double check it in this equation too, just to make sure that it works. So I'm going to just do this on my calculator. So 50 times 7. 50 times 7. Oh, come on. 50 times 7 equals 350 plus 150 equals 500. So yes, it works in both equations. So the answer is yes. And here's my explanation. I wrote a system of equations. I set them equal. And at 7 hours, they both equal $500. All right, there's your study guide. Good luck on the test. Bye.